Okay, in this clip, we're going to use flow measurements to calculate hydraulic conductivity for the sand in our flow model. So what we're going to do here, this is the flow net equation, we've looked at this. We're going to gather some flow, Q, over some period of time, okay? And then the rest of well, they're not really variables, but the rest of the items in the equation are known, okay? So we know the length, it's 15 centimeters. The head loss across the system, we've already measured that. This is what we're going to try to calculate. We know we have 3 flow channels, and we know we have 6 drops. So we're going to do this, we're going to measure the flow and the time for, in 2 trials, and then we'll take the average. Then we'll use those values and everything else we know to calculate hydraulic conductivity, and then we can take the average of those 2. So we're going to write that data down here for the 2 trials, the flow, the time, and we're also going to take the temperature. Okay. Typically, you report hydraulic conductivity, lowercase k, in terms of what it would be if the water was at 20 degrees. We call it K sub 20. Okay. And the reason is the viscosity of water changes with temperature, so we can compare apples to apples. We always normalize it to 20 degrees. And if you have a look on your data sheet, well, on the data sheet here for the one we're doing, this is the normalization process. We're going to report K20. We take K at the test temperature and multiply it by the ratio of viscosity of water at the test temperature to the viscosity of water at 20 degrees. And in this packet on PolyLearn, you have a table that has viscosity of water at different temperatures. Okay, so we're going to catch the flow here. So I'm going to start catching the flow. I'm going to start a timer. So we're catching some quantity of flow, capital Q. We have the timer going. I'm going to let this fill up most of the way. So this is a sand that we have here. This is sample C. We have 2 1D flow tests that we're going to do in Marriott bottles, and we'll look at those in other video clips, but there's sample A and there's sample B. The sand that's in sample A is the same as the sand that we have here in sample C. So the boundary conditions are different in the test, but we should get a similar value for hydraulic conductivity. Okay, so let's see, 48 seconds. We have 400, what are those? 5s, 10, 20, 25, yeah. So 415 milliliters in 48 seconds. 415 and 48, can you write that down? And we'll take the temperature at the end and assume it's the same for both trials, which is not likely to change in a couple of minutes here. It's a really awkward position I'm in holding this, by the way. Anyway. And 44, 45, 46, 47, 48. We'll do the 48 again. And this looks like it's 420 this time. So, pretty close. With the temperature, so you can correct your values to K20. It's like 18 degrees, so we have a little correction to do there. Now you have everything you need to calculate your K value and take the average.